All right, this is lesson 4.3, writing equations of parallel and perpendicular lines. Perpendicular. What's perpendicular mean? I remember that. Perpendicular is a right angle, for those of you who did not know what that meant. I kind of liked it way over here. Let me put it back over here. Yes, ma'am.
So perpendicular, you told us it's a right angle. Is that a 90-degree angle?
Yes.
If you search it up again, it's a 90-degree.
Same thing. Oh, that's so tiny.
What?
All right. I can see. That's better. Okay, so tell me what the definition of a parallel line is.
Two lines, same plane, are the same plane and never intersect.
Two lines that never intersect. What is a real life example of parallel lines? No? The yellow lines on the road? Sure. Mostly. There's exceptions to that. A train track is where my brain went. Train tracks. Okay, train tracks, those two parallel lines, they never cross over unless they're crossing over another set of parallel lines. Okay? And they're in the same plane. That they're telling you that because later on you're going to deal with different planes. So where you have a plane going this way and a plane going this way, and you have a line going this way and a line going this way, and they never touch each other, which is a very interesting concept. You'll get there. That's algebra 2. So let's look at example 1. Put this in your journal. So we're going to determine which of these lines are parallel. When you're talking about a parallel line, what equation can we use to determine whether lines are parallel? What's the equation called? Slope-intercept form. Which is taking close thunder because you're not raising your hand. So yes, y equals mx plus b. So when we look at these three lines, do we think we know which one's not parallel? We think we can tell, but we're going to mathematically double check it by finding the slope to see. The other thing you need to look at is the y-intercept. If they're the same y-intercept, what do you know about the lines? It's on top of each other. They're the same line. So they have to have a different y-intercept in order for it to be parallel. So basically, we're checking the slopes. All right, how would I find the slopes of these lines? What equation am I using? Chloe. The other one.
Y equals x1 minus x2 and y minus 1.
Other way around. You're on the right equation, but it's y2 minus y1 over x2 minus x1. M equals, yes. Okay? So let's look at line A and find the slope. So they've plugged in 2 minus 3 for the y's and 1 minus a negative 4. What's 2 minus 3?
1.
And 1 minus a negative 4 is actually addition, which would be 5. And 2 minus 3 was a negative 1, correct?
Yeah.
So this is negative 1 over 5. So line A slope is 1/5. Where does it cross the y line? Just give me an estimate. Just over 2, yes? Good. I just want you to visually pay attention to that. But our slope is negative 1/5. Let's look at line B. So we have the y's, negative 1 minus 0 on top, and then 1 minus a negative 3 on the bottom. What is negative 1 minus 0? Negative 1. And what is 1 minus a negative 3?
4.
Addition to 4. So this is 1/4. Already, are these slopes the same? No. So we already know that these don't match, which you could kind of see it. So now we just need to see is line C match B or A?
Line C matches.
What do you think it is? You think it's A?
Yeah.
Let's find out. So, line C, we have -5 minus a -4, which is addition, and 2 minus a -3, also addition. What is -5 plus 4? -1. And what is 2 plus 3? Negative.
Oh, why look?
So our answer is -1/5. So which two lines are parallel?
A and C.
A and C. That is the question it asked. So make sure for your answer, you tell me line A and C are parallel. Okay, and then make sure you're circling your slopes so that I know what you solved. Yes, ma'am. Yes.
So what is line C and A have the same section?
Just put line A and C are parallel. You don't need that giant sentence.
Yeah.
I don't want to read it. You don't want to write it. Can you not wait till after class? Try and wait till after class. Any questions on this one? All right, example 2. All right, so we're going to write an equation of the line that passes through the point 5, -4 and is parallel to the line y equals 2x plus 3. Okay, we have all the information we need to create a new line. What do we know about these two lines? How are they going to compare if we know they're parallel? Same slope. What is the slope of our line that we're comparing to? 2. So on our new line, we could already plug in 2 where the slope is, correct? On our new line, we know we have a point. And we know we're going to have a new y-intercept. So what can I do with this to solve for the y-intercept? What is this? X and y, right?
Yeah.
So could I plug these in over here?
Yeah.
And then solve for b?
Yeah.
Yes. So we're going to write a new equation. We already know the slope is 2. So we plug in our 2. We plug in our x at 5, and we plug in our -4 at y. And we just put b for our y-intercept because that's what we're trying to solve. Now we only have one variable, so we can solve it. What is 2 times 5? 10. Subtract it to the other side, you get?
14.
-14 is our y-intercept. Can I rewrite my equation now? Y equals what?
Y equals 2x minus 14.
Very good. So our new line is y equals 2x minus 14. So this is all you have to write at the very end, is this little equation and then circle it. Because it's asking me, write an equation of the new line.
So we just get rid of the plus and make it in.
Yeah. So that's the original line. All the information you need out of here is the 2. Everything else, we don't care.
Why?
Because we are writing a parallel line to this line. So all I need to know about parallel lines is the slopes are the same. So I grab that number, start my new equation, plug my number in, and then I grab that number, plug it in for x and y. That's it.
All right.
Comprende?
Yeah.
All right, let's check. All right, so now we're going to talk about perpendicular lines. Somebody tell me the definition, besides Eliana. Bless your heart, I love you. Nico, tell me the definition of a perpendicular line.
All right. Perpendicular is two lines on the same plane that intersect, making right angles or 90 degrees.
Correct. So they make a right angle or 90 degrees. This little red box is the universal, hey, this is a 90-degree angle. If it doesn't have the red box, you cannot confirm it. It might look like a 90-degree angle, but if it doesn't have the red box, it's not telling you it's 90 degrees. Question?
There's like a negative reciprocal.
Yes, I'm getting to that. Okay? The thing you must know about perpendicular lines is their slopes are opposite sign. So if it's negative, you're going to make it positive. If it's positive, you're going to make it negative. And you flip the number. You make its reciprocal. So if it's a -2, what's the new sign? Just the sign. If it's a negative, it becomes a?
Positive.
And then the reciprocal of 2, you flip it upside down, it would be a? 1/2. Because this is 2/1 technically, right? So perpendicular lines are negative reciprocals or opposite reciprocals. Okay, if that's not in your journal, make sure you put that in your journal. Perpendicular lines, slopes are opposite reciprocal or negative reciprocal, whatever works for your brain.
Opposite?
Yep. Opposite reciprocal or negative reciprocal. Because a negative times a negative makes it a positive, so it still works. All right. So, our example 3. Determine which of these lines, if any, are parallel or perpendicular. So the first thing we need to do is put them in what form? Y equals mx plus b. Is this first one in y equals mx plus b?
Yes.
Excellent. So let's just deal with line B. How do I make that? Oh, they did it super fast. So let's do it. What do I move first?
X.
Yep, subtract the x to the other side. And then what's my next step? To move the 4 off the y? What do you do? Divide by 4. And you divide by 4 on both sections. So you'd have a negative, because remember it was a negative x because we subtracted it. So you'd have a negative 1/4 x plus 3 divided by 4. So that's your new line. It's just rearranged into slope-intercept form. Now let's do this last one. What do I move first?
Negative 2x.
So we add 2x over to this side. Okay, so we have 2x plus 16.
Yeah.
How do I get the y by itself?
Right?
Yep, divide what?
Negative.
Negative 8. So 16 divided by negative 8 and positive 2 divided by negative 8. Okay, so that would be negative 2 over 8, which reduces to what? 1 over 4x. And then 16 divided by negative 8 would be negative 2. All right, so now these are all in slope-intercept form, so now we can compare them. Parallel lines have what? Same slopes. Do any of these have the same slope?
No.
Nah.
Yes.
Oh, chicks
Yes.
have one.
Are they different y-intercepts?
Yeah.
So line B and C are what?
Perpendicular.
Parallel lines. Write that down. Line B and C are parallel. Parallel. Okay, now are there any that are perpendicular?
Would 2 and negative 2 be perpendicular? Because
Say that again.
would 2 and 2, negative 2 be perpendicular?
You mean A?
Yeah.
You're talking about A?
A and C are perpendicular.
Yeah, we're not looking at the y-intercept for perpendicular. We're looking at the slopes. So these are negative 1/4, and this is 4. Is 4 and negative 1/4 the opposite sign inverse?
Yeah.
Yes. So technically, A is perpendicular to B, and A is also perpendicular to C, which makes sense. B and C are going parallel, and A is just cutting across them. So you would say A is perpendicular to B and C. Any questions on that one?
So A is
Perpendicular to B and C. In your homework, as you're writing it, I will let you abbreviate perpendicular with perp. P-E-R-P. That's a long word. Perpendicular,
Thank you.
because it takes forever.
Parallel.
P-A-R. Those are not accurate acronyms or shorthand. That's Miss C's shorthand, so don't do it when you get to high school. But for me, you can shorten them.
Okay.
As long as it's a perpendicular.
Right. I don't think there's a shorthand. All right, example 4. Write an equation that passes through the negative 3, 1. So we have a new point. And is perpendicular to the line y equals 1/2 x plus 3. What do I need from that equation of a line?
Just the one half.
Just the 1/2. Now I'm doing perpendicular, so what's my new
Flip it.
slope?
So it'd be
Flip it
2.
how to-
Flip
Negative
it and change the sign. So it'd be a negative 2x. Very good. So if I were to write this in slope-intercept form with just the slope part, oh, they're doing point slope form. You don't have to. Huh. I would not have done it in point slope form. So we're going to do it my way. And just see if we like it
Okay, no.
the same. All right, so we have y equals, what's our new slope?
-2.
Negative 2x plus b. What is the point they want us to use?
-3 for 1.
So 1 goes here,
And -3.
and -3 goes where the x is, plus b. Now I can solve. What is -2 times 3?
6.
Okay, how do I move to 6?
Subtracting.
1 minus 6 is,
5.
so b is -5. So y equals -2x minus 5. Is that the same thing they got?
Yeah.
Yeah, I don't know why they did the long version. You can, if you like point slope form, you can do it in point slope form. Point slope form is tedious. It's not hard, but it's tedious. So just do it in slope intercept form. Simple. Don't make it hard. Any questions?
Nah.
Last example. Can I erase this? All right. The position of the helicopter search and rescue crew is shown in the graph. The shortest flight path to the shoreline is one that is perpendicular to the shoreline. Write an equation that represents its path. So they're telling you the green line and the red line are perpendicular, correct? So what do we know about their slope? Which means it's opposite inverse, correct, of each other. Write an equation that represents the path of the red line, yes? See, my brain just wants to find another point on here and tell you what the slope of the equation is. Oh, well, you don't have the y-intercept. That's why. Okay. So, first, let's find the slope of the line that represents the shoreline. So, the green line. So, how do we find the slope of this one? Find two nice, pretty points on here. There's a point there.
Yeah.
There's a point there. So, from here over to here, what did I do? I went down how many?
3.
Nope. Start here. Down 2 over 3. So my slope is -2/3. You went down. So write that down. -2/3. This is the green line. So you can say y equals -2/3 x plus b is your green line. Well, the b is annoying, so no. We don't care about the y-intercept or the green line because we just need the slope, because the slope tells us this slope, right?
Yep.
Because what is this slope?
3 over 2.
Opposite inverse. Chloe looks confused. It's -2/3. I'm going kind of fast. This is -2/3, right? As my slope. Does that make sense, Chloe? Because I just grabbed 2 points on this graph. This was a point, this was a point, and I just counted down. 1, 2 over 3. So -2 over 3 is my slope. The red line, you flip it and take away the sign. So if it's -2/3, it becomes 3 over 2 positive. Which makes sense. If I go from here to here, I go 1, 2, 3, 1, 2. So we know 3/2 is our slope for the red line. So now I just need to use this point to solve for b. Right? Because my slope is 3/2, which there they solved it. So, point slope form, no thanks. So y equals 3/2 x plus b. The point on the graph was what?
14,4.
14,4. So 4 is the y. 14 was x plus b. What's 3/2 of 14? 21? Question mark? Can I do math in my head?
21. Oh, wow.
Those of you who like to do math in your head, you want me to tell you how I did it?
Yeah, sure.
Look up here. Simplify this. How many times can 2 go into 14? 3 times 7 is 21. You're welcome.
3 times 4. Now I know.
Right, but I can't do 14 times 3 in my head. But I can do 7 times 3 in my head. All right, so how do I get b?
Subtract 21.
Yep, so what is 21? 4 minus 21?
No. No? Wait, yes.
Yeah.
It is.
Yes.
So then my new equation is y equals 3/2 x minus 17. Let's see if that's what they got. Oh, shocking, that's what they got.
Oh, yes.
It's like we did math correct. Any questions? I feel like I might have gone fast on that for you guys. I'm sorry if that was fast. But I know y'all just want to get it done. All right, so y'all have 5 problems for your homework. You have probably 12 minutes. I bet you could get it done. We all were late, so I'll keep a little after.